Hey guys, just wanted to say hi and talk about solutions, stoic a little bit. So I'm going to tackle this first question here. How many grams of aluminum are required to react with 35 milliliters of a 2.0 molar hydrochloric acid solution? It gives us an equation, chemical equation, and we have to balance it first. So in order to balance, we see here we have 2 hydrogens, so we want to put a 2 here. However, there's 3 chlorines, so if I put a 2 here, that's not going to satisfy it. So we're going to go ahead and find the least common multiple of 6. So we're going to put a 6 here. And if we have 6 there, then over here for hydrogen, we're going to put a 3. And then for the aluminum chloride, we're going to put a 2. And then since we have 2 aluminum chlorides, we need 2 aluminums. All right, so now that we've balanced it, our next step is to figure out how many moles of hydrochloric acid we're dealing with. So we're going to take an equation. So molarity is moles per liter. So we need to solve for moles. To solve for moles, we need to take the molarity and multiply it by liters. And right now we have milliliters, so we need to convert that into liters. So we divide it by 1,000. So 0.035 liters. So we're going to take the 0.035 liters and multiply it by our molarity of 2.0. And that's where we end up with a value of 0.070 moles. And that is of hydrochloric acid, so HCl. But the question says, how many grams of aluminum are required to react here? So if we have this many moles of hydrochloric acid, we need to convert moles of hydrochloric acid to moles of aluminum using our mole-to-mole ratio, which is our ratio here of 6:2. We can reduce it if you'd like. And then we need to convert moles of aluminum into grams of aluminum. So I'm going to start here with my moles of hydrochloric acid. So 0.070 moles of HCl over 1. I need to get rid of moles by putting it in the denominator. So moles of HCl here. And we're using our mole-to-mole ratio of our 6:2, right? So moles of aluminum is what I want, so it goes on top. And we use the coefficient. So aluminum has a coefficient of 2. Hydrochloric acid has a coefficient of 6. But again, it asks for grams. So since I need grams, I need to go one more step. So I need to get rid of moles of aluminum. And I need to go to grams of aluminum. And when we go moles to grams, we use our periodic table. So 1 mole equals the molar mass of aluminum. And in our class, we're using the molar mass rounded to the nearest tenths place. So 26.98 for aluminum. 26.98 is going to round to 27.0. So on our chart here, our work, 27.0 grams of aluminum equals, because when we go through it, we're going to be able to cancel out these two. And then we're going to cancel out moles of aluminum. We're going to be left with our grams of aluminum. So our unit's going to be grams of aluminum. And what we do is we multiply the top and divide by the bottom. So 0.070 times 2 times 27.0 divided by 6 equals. And when you type that into your calculator, you should get this value, 0.63 grams of aluminum. So that's our first question there, and I hope this little tutorial explains a little bit for you, and I hope you guys have a great day. Thanks. Bye.